We're going to start talking today about circles, and it's actually going to be in two chapters, chapter 10 and chapter 12. So I'm just calling this chapter 12, and we're going to go through it. So today you're going to learn lots of circle vocabulary. There's lots of vocab in this unit. So you might want to think about index cards for this unit, or some kind of other graphic organizer, and I can help with that for you guys. But we've got lots of vocab. We're going to learn about properties of central angles. We're going to talk about arc addition postulate and how to find arc lengths. So basically, a set of points, a circle is a set of all points equal distance from a given point called the center. So G is our center, and when we name a circle, we use this little circle with a dot in it so we don't mistake it for an O, and we say circle G. So they're the points that are totally the same distance all around G. Okay. We have a diameter, which is the segment that contains the center. So it's a line segment, and we've got two in this diagram. So we're going to name it as a line segment. We've got SU, which is right here. And then we have RT, which is right here. Okay, so those are my two diameters. We also have a radius, or radii, meaning 1, and that is a segment with one endpoint on the center and the other on the circle. So this would be a radius. So we've got GT, and it doesn't matter which one comes first when we're naming. It could be UG, okay, GQ, GR, and GS are all radii, and we spell that like that, and that's the plural. Okay. A semicircle is basically half of a circle. Okay, so from here to here. It is named using 3 points that it goes through. Okay, and it's also an arc. So an arc is just kind of a part of a circle. So the semicircle, we name it with 3 points. So STU, and we use an arc above it. Okay. Minor arcs are arcs that are smaller than a semicircle. So arcs that are less than half the circle. So like ST would be a minor arc. QU could be a minor arc. RS, you've got all these little minor arcs in there. So I'm just going to list a couple. RS, let me say QU, ST, and we use just 2 points to note an arc. A major arc is an arc that's larger than a semicircle, so it's got to be larger than the semicircle. So we're going to go here, start at U, and we could go to R. That's larger than a semicircle. And to distinguish between a minor arc and a major arc, we have to use the 2 endpoints. So let's use R and U, and then a point in between, like S. Okay, so RSU and RTU would be the same arc. Okay, when we have 3 points, it's major, 2 points are minor. Okay, RSU and RTU are the same arc. RU, okay, is just that minor arc because we're only using 2 points. So it goes this way around the circle, and we only use 2 points. So you need to, that's something that's important that you remember. Okay, so we have a central angle, and that's an angle whose vertex is at the center. That circle looks a little smished, doesn't it? Okay, so I have this angle here, and it would be angle RST is my central angle. So it's an angle whose vertex is at the center. and we usually name it with the endpoints on the circle. Now, the thing about a central angle is the measure of the arc is equal to the measure of its corresponding angle. So RT is going to be 50 degrees. Remember that there are 360 degrees total in a circle. We've talked about that several times this year. All right. So we have the arc addition postulate that basically says that the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Similar to the segment addition postulate, similar to the angle addition postulate. So basically what this says is that the measure of arc QS is equal to the measure of arc QR plus the measure of arc RS. Okay, so if I knew that this was 30 and this was 40, then the whole thing would be 70. So let's look at some examples. We're going to find the measure of the indicated arc. And we should probably have M's in front of all of these to indicate that we're asking for the measure. So if we're going to go with GJ, it's this right here. We have a right angle right here, a central angle, which is 90 degrees, so GJ is 90 degrees. If I want to go GJI, okay, so we said that this was 90. GJI starts at G, goes through J, and ends at I. Okay, so JI is this arc central angle is 151, so this arc is also 151 degrees. So 90 and 151 is 241 degrees. HGJ, now we have a semicircle. HGJ goes all the way here, and its endpoints are on the diameter. So that means that it is going to be half of circle. A whole circle is 360 degrees, so this is going to be 180 degrees. So that would mean that this is 90 degrees as well. And you wouldn't have even had to know about a semicircle because we have this on a line, right? And angles that are linear pairs add up to 180 degrees. All right, so now we have H, J, I. So that's going to be 180 plus 151. You guys know me and my math. I'm just going to write it out. My arithmetic. So 331 degrees. So now remember, HI only has two letters. So it's this arc right here. And it's adjacent to the last arc we looked at, this HJI here. And we know that was 331. So 360 minus 331 is 29 degrees. Okay. There's other ways you could have gone about it too. You could have known that this was 150, so it's on a semicircle, so 180 minus 151 is 129. So different ways that we can arrive at the same conclusion. Now, there's a difference. We're going to look at finding arc length. Kind of jumping. Yesterday, you looked at circumference. An arc length is the actual measurement, not the degrees. Okay? So the arc length is an actual measurement, linear measurement. Okay, so, for example, if we're measuring a tire, okay, and you're measuring part of the tire, you're looking at the circumference, and part of that would be your arc length. So it's also part of a circumference. So let's kind of rate that there. I can spell circumference. All right. So we can use the formula depending on whether we have the radius or the diameter. It's basically part of the circumference, and we know that we find the circumference either by 2 pi r or pi times the diameter. So there is that equation for, or the formula for the circumference. This measure of arc AB over 360 is just the part that of the circle that we're going over. So, for example, and this is supposed to be the darkened part of the arc, the circle. This is what we're trying to find. We know it's 120 degrees, but we want to know what its actual length is if the radius is 9. Okay. So we're going to do radius over 360, since we've got the radius. I'm sorry, we're going to get the degrees. And how did I notate it here? The measure. So we're going to do the measure of the arc. Whoa. Gone crazy. All right, the measure of the arc. And I'll just name it AB. The other thing you're going to see, though, is sometimes we call it a central angle, and we use this figure here. We talked about that with trig. So let's just say it's that central angle over 360 times 2 pi r. So the central angle is the same as the arc it intersects. So it's 120 over 360 times 2 times pi times 9. 120 over 360 simplifies to 1/3. 2 times 9 is 18 pi. And then 18 divided by 3 is 6. So the measurement is 6 pi inches. We can leave it in terms of pi, if the pi, because that's what it's asking us for. If we wanted to know the measurement, then we'd just multiply that by pi. Whenever you're using pi in your calculators, please use the pi button so we're all on the same page. All right, so what did I learn today? We had lots of circle vocabulary. We talked about properties of central angles. We talked about the arc addition postulate, and we talked about how to find arc length. So have a great night, and I will see you guys tomorrow.